Let's just do one more short video about tangents, and then we'll save areas for part 4. So it was very natural to ask for this cardioid, what were the places where the tangent was vertical or horizontal? Ooh, I don't want to do it wrong there. And we found this interesting fact that it's still going outward when it hits the x-axis, and then a little bit below is where it actually gets to its extremes in terms of left and right, and that's where the tangent is vertical. But that also motivates, hey, exactly how sloped is it when it hits the x-axis here and here? So that's really an easier question, though. Once we have this master formula, we don't have to do any equation solving. We just have to plug in the appropriate theta. And of course, on the x-axis, that could be theta equals 0 or theta equals pi, depending on plus or minus. So if we plug in 0, we get dy dx. So the sine is going to be 0. We're going to get 1 for the cosine. And we're going to get a minus 1 on the bottom for the cosine and 0 for the sine. So it's a very simple number. Turns out to be minus 1. So it's coming in, actually crossing at a 45-degree angle, going up and to the left that way. Not too shocking. Now this minus, we knew that had to be true. Once we knew this was as far right as it went, it's coming inward. So it's a good check that should be negative. If theta equals pi, we really should already know the answer. From the symmetry of this curve, we should be getting plus 1. And we get dy dx. Let's check it. When theta equals pi, sine of 2 pi, that's still 0. Cosine of pi is now negative 1. Sine of pi is still 0. Cosine of 2 pi is 1. This minus 1, they cancel and you get 1. So we could plug in whatever theta value we wanted and get what the slope is at various interesting points. But to me, these two are the most interesting. So now we've found exactly when it gets to these horizontals, the verticals, this horizontal, which was pretty obvious. We've already noted that there's some interesting cusp behavior there, which some people might refer to as a vertical tangent, but I think it's just much more interesting to say it's a cusp. And then we've seen that when it crosses the axis, it crosses with slope plus or minus 1. I think that's all I want to do in this one, and then we'll separate out the areas for a 4th video.